Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial demo. Um, this is the first of the ones I'm doing for Chapter 4 in the Reggies and Step book for my Java course. And this is going to be called MaxOfThreeInts. Okay, and this relates to really both of the exercises that I've assigned for homework. So it's a kind of a mix of the skills that you need for both of the exercises that I've assigned. So let's take a look. I've created a Chapter 4 demo project in Eclipse. And I'm going to go down to source, and I already had my solution in here, and now I've gotten rid of it now that I was able to make it work. So I already have a default package. So I'm going to say I want a new class, and I want to call this max of 3 ints, and I want it to have a main. So let's say finish, and we're going to get our code. Now, more and more often, what we're going to be doing is we're going to be taking the code that we create and trying to factor it into a method or methods that are real handy to use. Okay, because that's kind of step one on our road to learning about object-oriented Java and creating reusable code. Okay, so here are the requirements that we're trying to solve. We would like to create a method that does a calculation on more than one input. Okay, so we want to call the method. We want to pass it more than one parameter, and we want to get a single answer back. Okay, so we want the method to return one value, as methods can do. Okay, so I just thought for this, how about we do something a little different. Instead of calculating the average or calculating the sum or whatever of, say, 2 integers, let's pass in 3 ints, and let's find the one that has the highest value. Okay? So here's what we're going to do. We're going to create the method here, public static. We're going to return an int because the max of 3 ints is an int, right? They're all integer values, they're whole numbers. And then I'm going to call it max of 3 ints. And I like that because it kind of describes what it does. Okay, so I'm going to have to, in the formal parameter list, I'm going to have to declare 3 inputs. Okay, so we use the type int. We give it a parameter name first. Okay, and then how do we separate these from each other? They get separated by commas. So int first, int second, int third. Okay. And then we're going to use a set of curly braces to create the code block for the method. Now the method is lighting up with the red underline because we promised to return an int and we haven't, and it's going to light up until we do. So let's do the following thing. Let us declare a variable that's going to hold our answer. Okay, I like the term answer. Okay, it's not the same as the word result or return value or whatever. It's just a personal preference, okay? It's no more right than any other descriptive term. But these methods that return a value are always returning a return value, a result, an answer, and I like to use the standard name, so I'm always going to use answer. Your mileage is going to vary, so you pick one that is appealing to you, but clear to those that are going to have to maintain your code. Okay, so I want to declare int answer. Okay, I can do one of two things. I can assign an initial value here, in which case I'm not going to get any complaints from the compiler about the variable not being initialized. Or I can, let's just see how this looks. If I just say int answer, okay, I don't have to give it an initial value. I'm going to go down to the end, and the very last line in the method, I'm going to say return answer. Well, here's the problem here. The compiler thinks that it might be uninitialized. So I'm just going to, even though this maybe seem like extra code, I'm just going to say equals 0 up on the declaration. So now I'm just giving it an arbitrary initial value, and I can see that when I return it, it works. And what I like here is it quieting down the compiler complaints. And I find that soothing, okay? Okay, so we're going to pick either the first or the second or the third, and we're going to pick the one that is the maximum. What's the strategy that works for that? Well, the pattern that I want to show you here is when you want to pick the largest or the smallest of anything, okay? You can take the following approach, okay? You start at the beginning and you just assume that the first one is the largest and or is the smallest, depending upon what you're trying to record, okay? Or perhaps you're trying to keep both the largest and the smallest, okay? But the first one, since you've only found this one so far, it is both the largest and the smallest. Okay. So in this case, we're looking for the largest. So we're going to move that value from the first into our answer. Okay. And why is that? Well, that's because we're just going to assume the first one is the answer until we find out differently. Okay. So in fact, here's what I'm going to do here. I'm going to just make a comment, okay? Assume first is the max, okay? So how do we do that? Well, we assign the value to answer from first. Is it the max? Well, I don't know, okay? But the strategy I'm using is I'm going to assume the first one is, then I'm going to do comparisons from there. This strategy or pattern of programming goes on to the next one. We're just going to go to the next one and the next one and the next one. If it turns out that our original assumption was wrong, well, we're going to change what we're holding in answer. Okay? So the next thing that we want to do is check if second is larger than first. Save value, would you say this? Adjust answer if it is. Okay, so how are we going to compare the size of? So this is interesting. I'm saying check if second is larger than first. That's not exactly what I want to do. I want to compare it to answer. Answer's holding my current largest. Okay. In fact, I like the idea that maybe in this application, instead of using my standard variable named answer, how about I call it current largest? Well, I've got that variable name in a couple places. How am I going to do this? Well, I'm going to show you a new trick. It's part of the refactoring. And it's a typical use case that you're going to have a variable that you all of a sudden realize hasn't got as favorable of a name as you'd like. So what can you do? You highlight one occurrence of it. I typically highlight the first one. Okay. You right click and you pick on refactor and then you choose rename. Okay. And now I'm going to call it, let's call it current max. So current max, just type it right over top and then press enter and watch what happens. It has replaced all three. So the current max is equal to 0 in the beginning. Then we look at the first one and we say, okay, just say it's equal to the first one. That's our current maximum because we've only looked at one. So now, sorry, we don't want it as larger than current max. It didn't change the comment, although I think there is an option when you are refactoring. If you check a box, it will look for occurrences of that name in comments as well. But either I don't have that feature engaged or I didn't check the right box. Okay, so we've got that. So what's this real code going to look like? Well, we're going to say if second is greater than current max, then we're going to come in and we're going to assume that it's the max. So current max equals second. All right, that sounds good to me. Now, how do we know at this point what value is in current max? Does it still have what came in on first, or have we replaced it with what came in on second? We don't know. It depends on what the values of these parameters were when MaxOfThreeInts was called. Okay, all that we know is that the one that's in there now is the largest value we've gotten so far. Now, what if we passed it the same two values? Well, it doesn't really matter. We probably have it in there from first because second wasn't larger than current max, but because they're the same value, we don't care whether that max value was put in there from first or put in there from second. It's still the max value. Okay, so let's take the same approach on the next one. Okay. So copy it, paste it. So we're going to say if third is larger than current max, check if third is larger than current max, adjust answer if it is. So if third is greater than current max equals third. Okay, so if we have a group of inputs, okay, in this case we're getting a fixed number of them, 3, then we just assume that the first one is the maximum, and then we go on, we compare the next one, and if we swap every time we find one that's larger. When we come to the end, we're going to have the largest value in current max. And then, of course, we're going to return it. So I think I've got one more blank line, that maybe two more blank. Yeah, I like it like that. It's a little breezy, but I like it enough. Okay. And I think things are properly indented here, but just for the heck of it, I'm going to right click and say source format. And it got rid of an extra blank line somewhere. That looks pretty good. I like that. Okay, now how are we going to test this? Well, we're going to test this by calling it with well-chosen values and inspecting the output. Okay, so what is a group of well-chosen values? Well, let's say that let's have three increasing values, like 1, 2, 3, or 11, 22, 33. Let's try 11, 22, 33. Okay, so how do we do this? Well, even though we're passing back a value, we don't have to save that value. We can just simply print it. So I'm going to show you doing that. Sysout. Okay, so let's print max of 3 ints, and then let's pass 11, 22, 33. All right, that looks okay. So what are we thinking that we're going to get? Well, I'm hoping we're going to get 33, but what we want to do is we want to test, do we get the right answer when the max is in the third position? Okay, let's run it. Run as Java application. 33, that looks good. Okay, then let's test the second position and then the first. Okay, so that's what I'm going to do is I'm going to copy this twice. Okay, and so let's say 44, 66, 55. Okay, so we have the max in the second position, and then let's have it in the first. So let's say 99, 88. Now let's say 77, 88. Okay, so mix it up a bit. So our first test case, we're expecting to get 33. Our second test case, 66 from the second position. Our third test case, 99 from the first test position. Okay, let's give it a run. And we got what we expected. Okay. Now, one of the reasons that we got what we expected is this pattern that we followed here of making the assumption that the first one is the max, and then comparing the next and swapping, if appropriate, comparing the next and swapping if appropriate. That pattern, that way of solving the problem, is a classic pattern that works. Okay, so not surprising that when we went to test it, it works really well. Okay, it'd be good to test out a couple of other cases. What if they're all equal? Do we get any unexpected side effect? I wouldn't expect one, but let's see. What if we've got 99, 99, 99? Let's see if that has any effect on it. I wouldn't expect one, but this is a good test case. So let's give it a run. And the last one comes out 99. That's good. What about negative numbers? Okay. So let's do 3 of them. Okay. So let's have 1. Let's have 9. And then let's have negative 22. Now, negative 22 has a greater magnitude, but because of its sign, it should be less than 9. So we would be expecting to get 9. So let's save and run, and we've got 9. So the sign's being taken into consideration as well. So at this point, I've kind of run through all the test cases that I think are appropriate. And I've got a nice little method that's kind of a tool that I can use. It's kind of a general tool that gives me the MaxOfThreeInts. Okay, I've used a tried and true pattern in terms of the design and the execution of the code. And I've done a fairly good job of testing it with 5 test cases, and we didn't pick them randomly. We picked them as the kinds of things that go wrong here is when these things have different relationships. So we've kind of tested out all the things. What if the one that we're looking for is in each of the 3 positions? What if there are equal values? And what if we've got negative values? And we got the right behavior in each case. So we've learned a little bit about standard patterns for solving problems. We learned a little bit about designing a nice little method that takes multiple input parameters and passes back one value. And then we've learned some things about how to design our test cases to make sure that we have fully tested our method. So, having said that, I'm going to say bye until next time. Bye-bye.